Okay, so let's continue from what happens with the find path. Uh, Here, the find path, this will, as we go from I is equal to 0 to the number of paths which we have traversed at this particular case, which is the number of path which we have traversed at the end of the TSP, which we have got as a 6. So, as we reach until we reach I value is equal to 6, then I value is go on incrementing. So, initially, we start from path of 1. Then the path of one's um, each vertex will be broken into different individual tokens uh, uh, by using this string tokenizer and using this while loop for hash number tokens. So at each step when we take individual tokens, then we will increment. I'm sorry, we will update the path cost value. This point, the path cost value is 0 initially, which we have to as 0. So, for which we will add the cost of the previous value, which is considered, and the present kth value. So, I forgot to mention one thing. So, here again, integer pass int. Here we are converting basically the string into integer first. So here we are taking integer 1. Okay. So, now the cost of previous value and the present k value is considered, which is this case, which is 1 and 1. So which is 0. So the path cost will remain, value will remain 0 as it is. So then we will the next kth value which we will get is 2. So when k is equal to 2, the path cost is again updated with the 0 plus the cost of the k value, which is the previous value, which is okay. When we have calculated this, then we have changed the pre-value to k, which was present at this stage was 1. So when we reach when at k is equal to 2, the previous value will be 1. So for previous 1 and previous value is equal to 1 and k value is equal to 2, we will update the path cost value, so which was 0, and we will add this to present 1 comma 2, which is 10. So now the path cost is 10. Then we'll reach to the token, which is k is equal to 3. So when k is equal to 3, when k is equal to 3, the PC value is now 10, which is taken here, which will be updated as cost of the previous value, which was 2, and the present k value, which is 3. So cost of 2 to 3 is 9. So 10 plus 9 is made over here. So the path cost value is again incremented to 19. So now the further the token 4 will be considered. So when token k is equal to 4 is considered, the PC value will be again updated. And the cost of previous value, which is 3, which is with the current value 4. So we will move from cost means vertex 3 to 4, which cost is 12. So we will add this to the previous path. So now the current path cost after traveling 1 to 2 to 3, 3 to 4 will be 30. So after coming out of this while loop, that means we have consider all these tokens. So when you have considered all the tokens, all this path is finished. But this is not it. So we have to traverse from 4 to the initial vertex, which is 1 again. So we will add this present path cost value with the cost of this end vertex, which is 4, to uh, the initial vertex 1. So that is what we are making over here. The whatever the end vertex is, from there to 1 we will add, and we will assign it to the path cost value. So now here, which is updated as 39. So now path cost value is compared with minimum value, which was initially 999, which is some higher value, very high value, which we have to put as 9999. So 39 is minimum, right? So minimum value uh, is updated with this path cost value. And similarly, minimum index is updated with the ith value, which at this position is I is equal to 1. So minimum index is made as 1. So now for I is equal to 2. Now we have completed one iteration, then we will come to another iteration for I is equal to 2. When I is equal to 2, we will consider path of 2, which at the path of 2 from the TSP, which we call is 1 to 2, 2 to 4, 4 to 3. And again, when we are again coming inside this for loop, the path cost value, pre value, and k value are again set to the standard values. So I have underlined these lines. So, but the minimum value and minimum index is out of the for loop, right? So they will remain as it is. So now for I is equal to 2. For I is equal to 2, we will again, this path is reckoning to individual tokens, that is k is equal to 1, 2, 4, and 3 at each step. At each step, the path cost is again updated with the by when initially again a pre-value and k value will be 1. K value will be 1. So again it will remain 0 as it is. When token 2 is reached, we will take we'll update the path cost value with the cost of 1 to 2. So from 1 to 2, when we going from 1 to 2, the cost is 10. So 10 is updated over here. Similarly, for 4 and 3, then we will update these values, and we will finally get the value as 29. So this is not it. Again, we have to go from 3 to 1, right? So again, we will add from cost of 3 to 1. Cost of 3 to 1 is 6. So we will add this to the present path cost value. Then finally path cost value will be 35, which will be compared with the previous minimum value, which was unchanged and remained 39. So which will compare with this 39, then clearly 35 is the minimum value. So minimum value is updated as 35, and similarly minimum index is updated with the present ith value, which is 2. So is this it? No. Still we have for loop remaining. So now Now, uh, we'll take for I is equal to 3. I value is incremented. So now path of 3 is 1 to 3 to 2 to 4. Then again, these values are made standard. Then again, individual tokens are taken as 1, 3, 2, 4. Then similarly, path cost values are also updated. At this step, we will finally get it as 38, and for which we will add from 4 to 1, which is 8. 4 to 1, which is 8. So we will add and we will get as 46. But the previous, the present minimum value was 35. But is this path cost value, which is 46, is less than minimum value, which is 35? No. So it will remain as it is, and minimum value and minimum index remains unchanged. Then E is incremented, and for I is equal to 4, we have reached, and then again this while loop continues, and finally this at the end of this we will get the path cost value as 40, which is again compared with the previous value, which is again not lesser than, so this again remains unchanged. So then for I is equal to 5 and 6, similarly we will check, and at these cases also minimum value, the previous minimum value will be previous minimum value 35, which is still lesser, so then 43, and again for I is equal to 6 also we will get 47, which is still not lesser than the previous minimum value. So minimum value will be remain unchanged at the end. So as we reach over here, yes, as we end, as we reach over here, the minimum value and minimum index value will be 35 and 2. This 35 and 2, okay. This 35 and 2 is final now. So the path of minimum index will remain 2 itself. So path of 2, we will consider the path of 2 is as we can observe over here, this 1 to 2 to 4 to 3. For this particular path, we will uh, add a link to 1 again. So 1 to 2 to 4 to 3 to 1. So like this we will end we will reach the end of the uh, end of the path. So which we will print the using TSP path is and path of minimum index, which we will get it as which will finally get it as this line will finally print it as 1 to 2 to 4 to 3 and finally to 1, and the minimum value will be of course 35, which we got in the salt TSP itself. So this is how this program works. I hope is clear. So I will end this recording now.